Welcome to our math class, and our lesson for today is about operations on rational algebraic expressions. Before discussing operations on rational algebraic expressions, let's have first our learning objectives. After going through this module, you are expected to perform operations on rational algebraic expressions and solve problems involving rational algebraic expressions. Let us start with multiplying rational algebraic expressions. The product of two rational expressions is the product of the numerators divided by the product of the denominators. In symbols, it is a over b times c over d equals ac over bd, where b and d are not equal to 0. Examples. 1. Find the product of 2s over 4k times 3 over 2k squared. Let us solve. 2s over 4k times 3 over 2k squared equals 6s over 8k cubed. What we did here is we just multiplied 2s and 3. So we have 6s. And in our denominator, we have 4k times 2k squared is equal to 8k cubed. And as you can see, we can still simplify 6s over 8k cubed. 6 and 8 have common factor, and the common factor is 2. So 6 and 8 can be simplified. 6 divided by 2 is 3. And 8 divided by 2 is 4. So we can now have 3s over 4k cubed as our final answer. Now, let's have another solution. Let us just rewrite the given 2s over 4k times 3 over 2k squared. Before we multiply the given expressions, let us check if we can simplify the expression. And as you can see, we have 2 in the numerator and another 2 in the denominator. We can cancel out these 2. So we can have now 3s over 4k cubed. And this one is just the same with our solution 1. Two. Multiply and simplify x all over x squared minus 9 times x plus 3 all over y. Before we get the solution or before we solve the given expression, let us first factor x squared minus 9. And the factors are x plus 3 and x minus 3. Let us solve. Okay. Rewriting the given expression, we have x all over the quantity of x plus 3 times the quantity of x minus 3 times x plus 3 over y. Instead of writing x squared minus 9, you can write the factors of x squared minus 9 as x, the quantity of x plus 3 times the quantity of x minus 3 for us to easily simplify the expression. Let us solve. Okay. So multiply the numerator, we have x times the quantity of x plus 3 all over, okay, multiply all the given denominators. We have the quantity of x plus 3 times the quantity of x minus 3 times y. After that, as you can see in the given expression, in the numerator and the denominator, they have common factor. So we can simplify that. The common is x plus 3 in the numerator and x plus 3 in the denominator. So what's left in the numerator is just x, and in the denominator we have y times the quantity of x minus 3. And this can be our final answer. Or If you want to distribute y inside the parentheses, we can have x all over xy minus 3y. And this can also be our final answer. Okay? So let's proceed with the second one, dividing rational algebraic expressions. The quotient of two rational algebraic expressions is the product of the dividend and the reciprocal of the divisor. In symbols, we have a over b divided by c over d is equal to a over b times d over c is equal to ad over bc, where b, c, and d are not equal to 0. As you can see in the given expression, since the given is a division, we will just rewrite the dividend, which is a over b, then proceed to multiplication. And then we will get the reciprocal of this divisor, which is d over c. So we can have a times d is ad and b times c is bc. Some examples. 1. Find the quotient of m over 2 divided by m minus 2 all over m minus 1. Let us solve. So we have m over 2 divided by m minus 2 all over m minus 1. Okay? The first thing that we're going to do is write the given dividend, which is m over 2. And then, let's proceed to multiplication, but be sure that you will get the reciprocal of your divisor. It is now m minus 1 all over m minus 2. Okay? So let us multiply. We have m times the quantity of m minus 1 all over 2 times the quantity of m minus 2. As you can see, we cannot simplify that anymore, so therefore, that's the final answer. Or, if you want to distribute m and 2, we can now have m squared minus m, and then we have 2 times m is 2m, 2 times negative 2 is negative 4. This can also be a final answer. Second example, find the quotient of k squared minus 25 all over k plus 5 divided by k minus 5 all over k squared plus 6k plus 5. Before we continue, let us first get the factors of k squared plus 6k plus 5. There you go. So these are the factors, the quantity of k plus 5 and the quantity of k plus 1. Let us solve. Okay, by rewriting the given, k squared plus 6k plus 5 is substituted with the given factors. We have the quantity of k plus 5 times the quantity of k plus 1. Okay, what we're going to do next is copy the given dividend, which is k squared minus 25 all over k plus 5. Then proceed to multiplication operation and then get the reciprocal of the second expression or the divisor. So we can now have the quantity of k plus 5 times the quantity of k plus 1 all over k minus 5. Next, as you can see in our first expression or in our dividend, we have k squared minus 25 and it is also factorable. So let us factor that expression. So we have the quantity of k plus 5 times the quantity of k minus 5 all over k plus 5 times the quantity of k plus 5 times the quantity of k plus 1 all over k minus 5. Okay. After that, we can simplify or we can cancel out k plus 5 over k plus 5 and then we have k minus 5 and another k minus 5 in the denominator. So what's left is the pink one, which is the quantity of k plus 5 over k plus 1. So therefore, this is now our final answer. Okay? So let's now proceed with adding and subtracting similar rational algebraic expressions. In adding or subtracting similar rational expressions, add or subtract the numerators and write the answer in the numerator of the result over the common denominator. In symbols, it is a over b plus c over b is equal to a plus c over b, where b is not equal to 0. As you can see, their denominators are the same, which is b. So you will just copy the denominator and then add the numerator. So a plus c. Same with subtraction. It's a over b minus c over b is equal to a minus c all over b, where b is not equal to 0. Examples. 1. Find the sum of 3 over 6b and 1 over 6b. Okay, let us solve. By rewriting the given expression, it's 3 over 6b plus 1 over 6b. So we can now have 3 plus 1 is 4 over 6b. We just copied the denominator. And as you can see, we can still simplify the expression 4 over 6b because 4 and 6 have common factor. And their common is 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. So therefore, we have 2 over 3b as our final answer. Next, add x all over x squared minus 4 and 2 all over x squared minus 4. Let's solve. X all over x squared minus 4 plus 2 all over x squared minus 4 equals x plus 2 all over x squared minus 4. As you can see, in our denominator, you can still factor, x squared minus 4 is factorable. So let's try factoring x squared minus 4. Rewriting the numerator, we have x plus 2, and the factors for x squared minus 4 are the quantity of x plus 2 times the quantity of x minus 2. And as you can see, we can simplify the expression by canceling x plus 2 in the numerator and x plus 2 in the denominator. So what's left in the numerator is just 1, and then in the denominator is x minus 2. So our final answer is 1 all over x minus 2. Let us continue. Subtract 4 over a minus 1 minus 3 all over a minus 1. This is very easy. Just copy the given. It's 4 over a minus 1 minus 3 all over a minus 1 equals 4 minus 3 all over a minus 1. Let us simplify. 4 minus 3 is 1 all over a minus 1. And this is our final answer. Okay, fourth example. Subtract 3n minus 1 over 12 minus n minus 5 all over 12. Okay, let us solve. 3n minus 1 all over 12 minus n minus 5 all over 12 equals. Okay, so rewrite 3n minus 1 minus the quantity of n minus 5 all over 12. We will put parentheses in n minus 5 since the operation is subtraction and the n minus 5 is a binomial. So we will distribute the negative sign inside the parentheses, in each term inside the parentheses. Okay, let's proceed. So we have 3n minus 1. Negative times n is negative n. Negative times negative 5 is positive 5 all over 12. Next is combining like terms. So how do we combine like terms? 3n minus n is equal to 2n. Negative 1 plus 5 is positive 4 all over 12. Okay. After that, as you can see in our numerator, 2n plus 4, they have common factor. So the common factor in 2n plus 4 is 2. So we can have 2 times the quantity of n plus 2 all over 12. And 2 and 12 can be simplified because the common factor is 2. So 2 divided by 2 is 1, and 12 divided by 2 is 6. So what's left in the numerator is just n plus 2, and in the denominator is 6. So therefore, our final answer is n plus 2 all over 6. Okay, so let's proceed in adding and subtracting the similar rational algebraic expressions. In adding or subtracting the similar rational expressions, change the rational algebraic expressions using the least common denominator or the LCD, and proceed as in adding similar fractions. In symbols, it's a over b plus c over d equals ad plus bc all over bd, where b and d are not equal to 0. Same with the subtraction. We have a over b minus c over d equals ad minus bc all over bd, where b and d are also not equal to 0. Okay, let's have examples. 1. Find the sum of 2m all over m minus 1 and 3 all over m plus 4. Okay, so let us solve. The first thing that we're going to do is find the LCD. As you can see, our denominators are m minus 1 and m plus 4. Since they have no common factors, therefore, we will get those denominators as our LCD. So our LCD is the quantity of m minus 1 times the quantity of m plus 4. Let us solve. 2m all over m minus 1 plus 3 all over m plus 4 equals, okay, so let us write the LCD, which is the quantity of m minus 1 times the quantity of m plus 4. Next, the given denominator m minus 1 times the quantity of m plus 4 will be divided in the denominator of the first expression or the first term, which is m minus 1. So m minus 1 times the quantity of m plus 4 divided by m minus 1 multiplied to 2m. And this is the result. So we have 2m times the quantity of m plus 4. Next, plus. So m minus 1, the denominator, our denominator m minus 1 times the quantity of m plus 4 is divided to m plus 4 multiplied to 3. So we have plus 3 times the quantity of m minus 1. Next, let us distribute 2m inside the parentheses and also 3. Okay, so we have, let us write the denominator, which is the quantity of m minus 1 times the quantity of m plus 4. 2m times m is 2m squared. 2m times 4 is 8m or plus 8m. 3m or 3 times m is 3m. It's positive 3m. Positive 3 times negative 1 is negative 3. After this, let us combine like terms. Since 2m squared have no common term, so therefore, by the way, just write the denominator. And since 2m squared have no common term, therefore we will just rewrite 2m squared. And as you can see, 8m and 3m are like terms. So we can combine them or we can add them. 8m plus 3m is 11m. Negative 3 has no common term also. So let us write negative 3 or minus 3. So as you can see, we can now or we cannot simplify this anymore. So therefore, this is now our final answer. It's 2m squared plus 11m minus 3 all over the quantity of m minus 1 times the quantity of m plus 4. Okay, I have note here, correction in module, illustrative example number 4, page 14. So I also use the examples in our module, page 14. Unfortunately, there is a typographical error maybe, so this is the correct answer for that example. Okay, let's proceed with our example. Find the sum of 4x all over x squared minus 5x plus 6 and 5x all over x squared minus 4x plus 4. Okay, let us first get the factors of the given denominators for us to easily get the LCD. So, in x squared minus 5x plus 6, the factors are x minus 3 and x minus 2. For x squared minus 4x plus 4, the factors are x minus 2 times the quantity of x minus 2. Let us solve. Let us find the LCD. As you can see, we have to get their common factors. So in our given factors, the common are x minus 2 and x minus 2. And since x minus 3 have no common factor, same with the other x minus 2, so therefore we will rewrite those. And x minus 2, in common, in 2x minus 2, we will just get 1 as their common factor. So therefore, our LCD is the quantity of x minus 3 times the quantity of x minus 2 times the quantity of x minus 2. So x minus 3, this is the x minus 3 that I am talking about. And the x minus 2 that I am talking about is this one. How about the white font, the white one, which is the x minus 2? This is the combination, this one, x minus 2 and x minus 2. Just get one and I made this a white font. Okay, so these are the LCD. This is the LCD of our given expressions. Okay, so let us solve. For x all over x, the quantity of x minus 3 times the quantity of x minus 2 plus 5x all over the quantity of x minus 2 times the quantity of x minus 2. So instead of writing x squared minus 5x plus 6, I just write the factors of x squared minus 5x plus 6, which is the quantity of x minus 3 times the quantity of x minus 2. Same with the factors of x squared minus 4x plus 4. Okay? For us to easily simplify the expressions. Let us continue. Okay, so since we already have our LCD, which is this one, so let us write the LCD. The quantity of x minus 3 times the quantity of x minus 2 times the quantity of x minus 2. Let us divide this here and then multiply it here. Okay, so x minus the quantity of x minus 3 times the quantity of x minus 2 times the quantity of x minus 2 divided by the quantity of x minus 3 times the quantity of x minus 2 times 4x. And it is equal to 4x times the quantity of x minus 2. If you are still confused why the answer is this one, I will just show you this. X minus 3, I hope you understand, times the quantity of x minus 2 times the quantity of x minus 2, okay? So this one, divided by this, the denominator rather. Okay, so let us divide x minus 3, divide times rather, the quantity of x minus 2. So the operation here is division. So we will cancel out x minus 3 and x minus 3, and then x minus 3 over x minus 2. So what's left here is x minus 2. So this x minus 2 will be multiplied to 4x. So we have 4x times the quantity of x minus 2. Okay? So same pattern, same procedure here. So the quantity of x minus 3 times the quantity of x minus 2 times the quantity of x minus 2 divided by this one, the quantity of x minus 2 times the quantity of x minus 2 times 5x. So we have positive 5x times the quantity of x minus 3. Okay, next let us simplify. So rewrite the given denominator or our LCD. For x times x is 4x squared. For x times negative 2 is negative 8x. Positive 5x times x is positive 5x squared. Positive 5x times negative 3 is negative 15x. Just be sure guys that if you're going to multiply the terms, you have to include their signs. Okay? After that, let us combine like terms. Write again the given denominator or the LCD. So we have 4x squared plus 5x squared is 9x squared. Negative 8x minus 15x is negative 23x. And this is now our final answer. Okay? Let's continue. Subtract 3 all over x plus 2 minus 8 all over x minus 2. Let us solve. So let us find first the LCD. As you can see, our denominators have no common factor. So therefore, we will get them as our LCD. So our LCD is the quantity of x plus 2 times the quantity of x minus 2. So we have 3 over x plus 2 minus 8 all over x minus 2 equals. Okay, so we write the LCD, which is the quantity of x plus 2 times the quantity of x minus 2. Again, same procedure in adding the similar fraction. We will divide the quantity of x plus 2 times the quantity of x minus 2 in x plus 2 and then multiply it by 3. So we have 3 times the quantity of x minus 2 minus the quantity of x plus 2 times the quantity of x minus 2 divided by x minus 2 times 8. And we have negative 8 or a negative. So why is it negative? Because the operation here is minus. So we have minus 8 times the quantity of x plus 2. Let us continue. Okay, rewrite the denominator. So 3 times x is 3x. 3 times negative 2 is negative 6. Negative 8, just be careful, you have to include the sign. It's negative 8 times x is negative 8x. Negative 8 times 2 is negative 16. Okay? And then combine like terms. Rewrite the given denominator. So like terms are 3x and 8x or negative 8x. So we can combine, we can add or subtract. So 3x minus 8x is negative 5x. Negative 16 negative 6 minus 16 is negative 22. And this is now our final answer. Okay, let's proceed. Subtract 5 all over x squared plus 6x plus 9 minus 1 all over x squared minus 9. As you can see in our denominators, they are factorable. So let us factor them. For x squared plus 6x plus 9, the factors are x plus 3 times the quantity of x plus 3. For x squared minus 9, we have the quantity of x plus 3 times the quantity of x minus 3. Let us solve. Let's get first the LCD. As you can see, the common is x plus 3 and another one is x plus 3. The x plus 3, the pink one with x plus 3 have no common, and the other x minus 3 have no common factor also. So we will rewrite them as part of the LCD. And in x plus 3 and x plus 3, we will just get 1. So we have as our LCD the quantity of x plus 3 times the quantity of x plus 3 times the quantity of x minus 3. So x plus 3 natin, ito, wala siyang common, so kinapin natin as part of our LCD. And then this one is also our LCD. Then, since they are common, so we will just get 1. So this is the common, which is the quantity of x plus 3. Okay? So let us solve. So we have 5 all over the quantity of x plus 3 times the quantity of x plus 3 minus the quantity of x plus 3, 1 all over the quantity of x plus 3 times the quantity of x minus 3. Again, so instead of writing x squared plus 6x plus 9, what I wrote here is the factors of x squared plus 6x plus 9, which is the quantity of x plus 3 times the quantity of x plus 3. They are actually the same. The same with this one. So x squared minus 9, instead of writing x squared minus 9, so the quantity of x plus 3 times the quantity of x minus 3 ang inilagay ko. Okay. So next is, let's write the LCD. Okay, so since we're done getting the LCD, we will just rewrite it here. So there you go. We have the quantity of x plus 3 times the quantity of x plus 3 times the quantity of x minus 3. Again, for us to have the numerator, we will divide this one here and multiply it by 5. Okay, so we have 5 times the quantity of x minus 3. Okay, minus, we will divide this one also here, and then what's left is x plus 3. Diba? So we have times 1, we have negative 1 times the quantity of x plus 3. Okay, so I have here 1 here, but we can also remove 1 here, and we'll just write negative here. Okay, so let us continue. Let's proceed by simplifying. 5 times x is 5x. 5 times negative 3 is negative 15. Okay, next, let's proceed. Negative 1 times x is negative x. Negative 1 times 3 is negative 3. And then combining like terms, rewrite the given LCD or the denominator. So common terms or like terms are 5x and negative x. 5x minus x is 4x. Negative 15 minus 3 is negative 80. Okay, so there you go. So this is now our final answer. Okay, so these are the operations on rational algebraic expressions. I hope you understand these examples. So we can now proceed with the second one, which is solving word problems involving rational algebraic expressions. Okay, I have here one example only. I will present this. So 7 divided by the sum of a number and 2 is equal to half the difference of the number and 3. Find all such numbers. I will present you steps in solving word problems involving rational algebraic expressions. Okay, so the first step is what is asked. We have to find what is asked in the problem. So, what is asked in the problem is we're going to find the numbers. Next, write all the given. Note, use only one variable. Okay? So if we're gonna use x, we will just use x in the entire expression. If you want y, so use y in the entire expression. Okay, so let's have this one. So where did we get this one? So 7 all over x plus 2 and x minus 3 all over 2. So sa 7 all over x plus 2 is here 1. 7 divided by the sum of a number and 2. So our number here is x. So 7 divided by the sum of a number and 2. And then the other expression is half the difference of the number and 3. Half the difference. It can be this one. This came from half the difference of a number and 3. Okay, so this one. So I just simplified this. 1 half times the quantity of x minus 3. So we have the quantity of x minus 3 all over 2. Okay, so this and this are just the same. Okay, so let's proceed. Third, write the operations to be used and the equations to work on. Okay, so 7 all over x plus 2 equals x minus 3 all over 2. So why is it equal? Because let's go back to the given problem. According to the given, 7 divided by the sum of a number and 2 is equal to. So that's why may equal tayo. Is equal to half the difference of the number and 3. So let's proceed. Let us continue. So we have x all over x plus 2 equals x minus 3 all over 2. Okay, so write the solution. Fourth step, write the solution, apply the cross multiplication. Okay. Since this is an equation of irrational expressions, we can apply cross multiplication method. Okay, so how is that? So we have 7 all over x plus 2 equals x minus 3 all over 2. So we will multiply, cross multiply, say x plus 2 and x minus 3. We will get the product of these two binomials. So we have the quantity of x plus 2 times the quantity of x minus 3. Okay? And then equals, we will now multiply 7 and 2. So we have equals 7 times 2. So let us now solve. So by using FOIL method, we will get the product. X times x is x squared. X times negative 3 is negative 3x. 2 times x is 2x. And 2 times negative 3 is negative 6. If you can easily get the product of the two given binomials without having use of a FOIL method, okay lang din naman. Much better for us to easily get the product. Okay. Equals 7 times 2 is 14. Next is, let us simplify by combining like terms. So how do we simplify that? Okay. So si 3x and 2x are like terms. So therefore, we have x squared minus x minus 6 equals 14. Okay, there you go. So we have still another like terms. So si negative 6 and 14. So what we're gonna do in 14 is we will transfer it to the other side of the expression. Or we can use the subtraction property of equality. So we can have x squared minus x minus 20 is equal to 0. Why do we have minus 20 here? So as I've told earlier, we can use subtraction property of equality. So si 14 will be transferred here. So negative 6 minus 14 is negative 20. So if we're going to use the subtraction property, so it's x squared minus x minus 6 minus 14 equals 14 minus 14. to make this 0. Okay, so we have x squared minus x minus 20 equals 0. After this, as you can see, this expression is now factorable. And the factors for that is the quantity of x minus 5 times the quantity of x plus 4 is equal to 0. After that, we can equate x minus 5 to 0 and same with x plus 4. Okay, by equating it to 0, x minus 5 will become x is equal to 5 and x plus 4 is now x is equal to negative 4. Okay, how does it happen? So x minus 5 is equal to 0. So we will get the value of x. So we will transfer it to the other side of the expression. It will become x is equal to 5. So ayun yun. Same with x plus 4. We have x plus 4 is equal to 0, getting the value of x. So we have x is negative 4. At eto din naman yun. Okay, there you go. So let us write our final answer. Okay, so if our x is 5, then the number is 1. And if x is equal to negative 4, the number is negative 7 over 2. So how did we get 1 and negative 7 over 2? By substituting the value of x in the given expression, that's why we have 1. So if x is 5, 7 all over 5 plus 2. So 5 plus 2 is 7. 7 divided by 7 is equal to 1. Okay? And if it's negative 4, it's 7 all over negative 4 plus 2. And negative 4 plus 2 is negative 2. So it's negative 7 over 2. Since these two are equal to each other, therefore if we will substitute x as equal to 5 here, it's still 1. Kasi 5 minus 3 is 2, and 2 divided by 2 is equal to 1. And if the value of x is negative 4, negative 4 minus 3 is negative 7 all over 2. So therefore, these two are the final answers. The two numbers are negative 4 and negative 7. Okay, so that's all for today. I am your math teacher, Catherine C. Ramos. Thank you and God bless.